Okay. All right. All right. Quiet, please. So outcomes. All right. So today, this lecture, we'll continue on with how does the manometer works. That's the continue from the fluid statics we did on last Thursday. All right. We'll discuss what is pressure. All right. Gauge pressure, absolute pressure, absolute. So you cannot read this one. Okay, gauge, absolute, what else? Pressure head, and so on. Okay, and we'll also talk about buoyancy, and if you can find, how to calculate forces. We'll start a little bit anyway. Forces on a submerged surface. How to evaluate buoyancy forces. Okay, so that's our lecture plan anyway. All right. Hey, still very noisy, huh? You okay? All right. It's a bit warm in here, but I don't know, Monday always like that. Huh? Okay. Anyway, by the time I do anything, the lecture will be over, so let's just continue. Okay. Have to warm up a bit for the week. Okay. All right. So let's recap. If this was fluid, if consider this point and this point on the same height, is the pressure same or not? P1, P2. Okay, what happens if the tank look like this? Still same, isn't it? Okay, so no matter what shape the tank, all right, so they give you all sorts of funny shapes to mess you up with. Okay, as long as the fluid is still connected, the pressure should be the same. Okay. If this point here, P3, which is below P2, alright, so P3, pressure higher or lower than P2? Alright, let's say this head. So P3 is higher than P2, that's why P3 minus P2 is a positive number, is equal to rho G H. Rho is the rho of this liquid. Okay or not? Alright, that's what we calculated. That's why I showed last week. So, or if you want another way, you can write dP on dy is equal to minus rho g. Okay? So in other words, the pressure gradient is rho g. Okay? So negative because you go down, the pressure goes up. Okay or not? Because this is y is this direction, you go down, the pressure go up. Y or z up to you. Okay, I use Z. I think normally they use Z this way. So Z. Okay, so you go down in Z, the pressure go up. Okay, so now let's think about it like this. If you have a pipe, okay. All right, now let's say the pipe, there's no flow in the pipe. Okay, here, this one got water inside. So water density of water is 998. Okay, kilograms per meter cube water. All right, so we have a pipe. Okay, now there's a valve and we close off the valve. Okay. All right. Again, this could be the tap in your valve in your house. And I have a two T junctions here. With the valve closed, okay, no water flowing there. If I have a hole in the tap, the water will come out, isn't it? Correct or not? If I hold in the tap here, the water will come out, isn't it? Okay, but instead of having a hole, I put a T branch, okay, and go upwards. At some time it will stop, isn't it? Correct or not? Or can go up for forever. Alright? Up to 2 kilometer up also still can go. Alright? No, isn't it? It will stop. Correct or not? Okay, it will stop. Alright? And I have another T branch here. I'll talk about this later on. But if the water is not flowing, by right, this height should be same or not? Yes. Why? Because pressure here, P2, P1, should be the same one. Okay, water not flowing. Okay, so I can know what the pressure in my pipe, my water pressure when the valve is turned off. There must be some pressure. Not, and you turn on the valve, the water won't flow. So, why not? Okay, so there must be some pressure in that pipe. So here is P atmosphere. Here is P1. So can I say P1 obviously is higher than P atmosphere. This again is the H. P1 minus P atmosphere is equal to rho of the water GH. Is that correct? Alright. Okay. Then, what should I do next? Should I open the pipe? Okay. So if I open the pipe, alright, then the water starts flowing out here. I will notice that maybe these are not here anymore. Alright. This one will drop. This is the original height. Will this one be the same as this one or not? This one will drop even more, isn't it? Okay. That's what you did in your flow measurement, pipe flow experiment. For those who haven't done, who did it in week 1. You had water flowing your pipe, you measured the two heights. Okay? But why not the same now? Okay? Why is P1 not the same as P2? Why? Alright? You don't know now, but intuitively you say, oh, there must be some losses in the pipe. Some friction, isn't it? You're moving water. Water has viscosity, is rubbing against the wall. You lose some heat. You lose some energy. Correct or not? Alright? So you lose some energy, there's some losses. Alright? We'll talk more about pipe flow losses later. But for now, let's just assume that there's some losses. Okay? So here, now this becomes H1. This becomes H2. Okay, so since the water is flowing in here, we cannot say anything about that part. Okay, but we still can say here is still atmospheric and here is atmospheric. Okay or not? Alright, just because you turn on the pipe doesn't mean the pressure of the atmosphere changes. It still stays the same. Okay, so can we say P1, so this is the no flow, then we get 1, P1 equals to P2. Okay, then with the flow, when water flowing, I can say P1 minus P atmosphere is equal to rho G H1. P2 minus P atmosphere is equal to rho G H2. So I subtract the two. Can I say P1 minus P2 is equal to rho G H1 minus H2? Correct or not? Alright? So that's how a manometer works. Okay? You are able to tell the difference in pressure. Okay? Based on the difference in height. Okay or not? Any questions? So here, if you start now, here sorry, here is 1, here is 2. I take 1, equation 1 minus equation 2 equals, you get this. Okay or not? So with this one, we are able to measure the pressure, or at least the difference in pressure, all right, in this pipe. We don't know what's happening in the pipe, so we don't analyze down this way, all right. Don't suddenly say, all right, the pressure here is same as the pressure here, correct or not? Yes or no? Okay. Anyone believe the pressure here is the same as the pressure here, same height, same fluid? No, because although the fluid is connected, but it's not connected by stationary fluid. Alright? Same height, same fluid, connected but stationary fluid, then the pressure is the same. Alright? Same height, same fluid, but the fluid connected, but the fluid not stationary, then the pressure may be different. Okay? So this pressure, so the pressure at this point and the pressure at this point may not be the same. Okay? Okay. Any questions? So far this is the easy one. Let's make it a bit more difficult. Alright. Let's go. Some manometer got 2 fluid, some got 3 fluid and all that also. Alright. Just to make you a bit more confused. Alright. So let's do one with more than 2 fluids. You okay with this? Any questions? Alright. So let's see here. Chamber. PA. Pressure A, say. Alright. Okay. So let's say inside here is all water. Alright. Again, maybe this is a pipe, maybe this is some tank, water tank or whatever. Okay. So normally manometer go like this. Okay, very complicated already. Alright, so we got water. Let's say we got a lighter fluid in here. Alright. Down. Okay, let's just make it lighter fluid here. Alright, let's say this is oil. Raw oil equals to 700. So this is water. This is water, so water maybe up to here. This is also water. Okay or not? Alright, and we want to find the pressure here, PA. Here we open, here is atmospheric, P atmospheric. Okay, so here you call this H1. Here I call this H2. Here I call this say H3. Okay or not? Alright. So we have some oil in here which is lighter, that's why it floats up. Okay. And we have a manometer. So we want to find pressure at A. Alright. Make it nice and confusing for you. Confused again or not? Alright. So let's start. Where to start? So look for where the fluid is connected and at the same height. So obviously I cannot, it'd be nice to go straight from here to here, but the pressure here and here same or not? Yes or no? No, because not directly connected. Okay. Alright, so we start from this fluid is connected. You start here. Okay, this height, pressure is the same. Okay, let's call it 0.1. Alright. So on the left hand side, this one needs to go down and then needs to go up again. This one pressure same or not? That's 2. Okay, and that one. Alright. Here and here pressure same or not? Because of that, here continuous, liquid, stationary, all these things. So yes, P1. Okay. Yes, 1 also. Okay. Now not so difficult here. I got 1 and 2 here. Okay, so on here I do more slowly, but later on you can speed things up lah. Okay, once you're familiar. So can I say P2 minus P atmosphere is equal to rho water GH1 from here to here? Okay or not? Okay. Then from here to here, P2 minus P1, 2 is lower than 1 again, is equal to rho oil GH2. And from here to here, final one, 1, 1, 1, no need, P1 equals P1, P1. PA minus P1 minus PA, P1 minus PA is equal to rho water GH3. Okay, I don't want 1 and 2, I just want PA and P atmosphere. How to do it? 1, 2, 3. Cannot see. So I call this equation A, I call this equation B, I call this equation C. Alright, can I say A minus B plus C? Okay, A minus B is what? P2 minus P2 gone, minus P atmosphere, minus P1. So I get P1 minus P atmosphere. I'll do in 3 steps. Alright, is equal to rho water GH1 minus rho oil GH2. Is that okay or not? Okay or not so far? Yes or no? Did I make a mistake? Alright, and I take this equation and minus C. Okay? Did I make a mistake? P2 minus P2 gone, minus P atmosphere, minus P1. Correct. So, minus C again. So, P1 minus P1, no more. So, I get PA minus P atmosphere. Because minus PA minus C, so get gone, is equal to rho water GH1 minus rho oil GH2 minus rho water GH3. Alright. So if you want, you can summarize that. PA minus P atmosphere is equal to rho water GH1 minus H3 minus rho oil GH2. Okay or not? Alright. So with manometer problems, generally this is your approach. Alright. So we can work out what PA and P atmosphere is as long as we can measure all the heights. H1, H2 and H3. Okay. Any questions? Alright. Yeah. Okay. Alright, pressure. So far we talk about pressure. Okay. Alright. Alright. And pressure, normally our units is Pascal, which is equal to newtons per meter square. Right or not? Okay. So, but there are other ways of expressing pressure. Okay. But first, let's start. All right. Let's start. Gauge pressure absolute. All right. You all heard of the term gauge pressure and absolute pressure before? Yes or no? Yes? Yes or no? No. Okay, some say yes, some say no. Alright? So gauge pressure is what the pressure gauge measures are. Alright? Can I turn this on? Turns on. And I'm supposed to press some button here. Yeah, no. Okay. Alright, so this is a pressure gauge. Okay. Yeah. So don't panic. The here this pressure gauge I bought here, and Malaysia, although we're supposed to use SI units, a lot of people don't. Okay. By right they should. Right? It's against the law not to, but so by right, when they sell you land, they're supposed to tell you how many square meter, not supposed to tell you how many square feet. Alright, so all the legal contracts should be written there. Alright, if not, get problem. So by right, it should be. If not, you end up in problems. Okay. But so anyway, I bought this pressure gauge. Okay. Bar is I think SI units. So 1 bar is normally equal to 101 kPa. Why? Yeah? Alright? Because that is equal to 1/8 atmosphere at sea level. Okay? Alright? So here 0, 1 bar, 2 bar, 3 bar is 2 atmospheres, 1 atmosphere, 2 atmosphere, 3 atmosphere. Okay? PSI is stands for pounds per square inch. Alright? Which we won't use so much. Okay? But there's a 1 PS. I think 1 bar is around 14 and a bit PSI. Okay? So, but still a lot of people use PSI in Malaysia, but that's not supposed to be. Okay? Alright? What's the pressure reading now at the moment? So, should you be alive at 0 or not? So, vacuum, isn't it? So, this pressure gauge broken already. Right? So, either you should not be alive, your blood will boil. That would happen if you are in your spaceship and you open the door, your blood will boil before you die. Or maybe you die first and blood boil. Whichever happens. Alright? So, something wrong, isn't it? Okay? So what this pressure is measuring is the pressure in this hole here. Alright, there's a hole here. Okay? So it's the pressure between this hole and what? And the atmosphere around it. Okay? So what's actually inside the pressure gauge? Alright, for those who alright? Okay? So this one is still very old fashioned. You need to go up and read it. Okay? Next time when you go and work, alright? That's the only time you get to look at pressure gauge and use manometer and all that is now. So you should treasure it. Next time when you go and work, all these automated one. Just maybe even 10 years ago, if you're in the process plant or any other plant, you've got a big nice white control room, all the dials on there all the display, all electronic display for you to tell you what's going on, what's the temperature of this process and so on. I think lately it's not already happening. Soon all that information will download to your iPad or your tablet. Okay, so you can see there everything. Don't need to go to office room. Okay, you can monitor how's the process going. Okay. Then at night got any problem, your iPad will ring and then you have to go and see what's wrong. Okay. Alright. So come back to here. Okay, so this one quite primitive, you might not see many more. Alright, what's actually inside this pressure gauge is like when you know when you go to a party and you blow that thing that's coiled up. Alright, what's it called? Huh? You know the whistle like this, it's coiled up with paper. Oh, cannot see, yeah. Okay, switch over. Okay, you see now this one, so we switch over. Alright. When you go to a party, you there's this thing that's coiled up like a piece of paper like this. And then you blow, when you blow it straightens out. Seen before or not? Huh? Okay. So inside this mechanical pressure gauge is basically something like this. Alright? So inside here there's a coiled up like a snail inside here. Coiled up piece of, normally depends on what material is made of, sometimes brass, sometimes stainless steel and so on. There's a coiled up piece of spring in here. Alright? With a channel opening inside. So as the pressure builds up inside, that piece of spring we want to straighten out. Just like when you blow the party whistle, that thing straightens out. Try not. Alright? And when that thing wants to straighten out, it will move this down. Okay? That's how it works. So it relies on the pressure difference between inside here and the atmospheric pressure. Right now, inside here and the atmospheric pressure is the same. That's why it's reading 0. Is that okay? But if the atmospheric pressure, so this one, that's why we call it gauge pressure. It's just the pressure between this one, between here and atmosphere. Alright? So normally, alright, but not all the time lah. Okay? Normally the atmospheric pressure is 101 kPa. But in some rare instances where you have to work at high altitude and so on, the pressure might be different. Okay? Alright? But normally we can consider for this unit, the atmospheric pressure is 101 kPa. So now that one is measuring 0 kPa. So the gauge pressure is 0 kPa. So at sea level, well, your absolute pressure is 101 kPa and your gauge pressure is 0 kPa. Alright? Because I think P absolute, so P absolute, why do they call it absolute? Because it's absolute. Alright? Similar to the vodka you drink. For those who can drink, if they're old enough and their religion don't know, right? Okay, P absolute is equal to P gauge plus P APM. Okay, I think that's the, okay? So normally this one, but not in all cases, alright? Suddenly you have to operate, you have to build a plant up in a mountain, maybe Mexico City or what, then this one may not be the same. Okay? Not likely, but you know, if you work in Cameron Highlands or what, maybe this one not the same. Alright? Okay? So, alright? So if your gauge pressure read, example, your gauge pressure read 50 kPa. So, let's say, example, then your absolute pressure is 151 kPa. Is that okay or not? Alright? And you can use this formula to go whichever way it needs. Alright? So normally, absolute pressure we only use when we need to work out cavitation. Alright, cavitation is the process, remember the vapor pressure? Cavitation, vapor pressure. Alright, so those ones rely on absolute pressure. Okay, the boiling point relies on absolute pressure. Those fluid, and you know the ideal gas? All right. Some of you from science, P small v equals to nRT. All right. Depends. Scientists use like this. Engineers use like this. All right. So those that done thermo, they use like this. Those that done science and chemistry, all that, they use like this. All right. When you use the ideal gas equation and other things that rely on fluid the properties, then you need to use absolute pressure. All right. But for this unit, most of the time, gauge pressure is enough. This unit. All right. Okay. Most of this unit. Okay, and I'll show you why soon. Okay, so we've covered pressure, gauge pressure, absolute pressure. Any questions? Absolute. All right. So this one, cavitation, vapor pressure. All right. Cavitation I explained last week. Check direct the notes. All right. Any questions? All right. Okay. So, what else do you need? Okay. So you ever, I think all have to do medical, isn't it? No, only the international students have to do medical. You need student visa, isn't it? Only right? You didn't do right? No, local students don't need to do. Huh? International students don't need to do. Huh? You did, right? Okay. But local students, sometimes you go doctor also. Doctor take your blood pressure. Right? International students, definitely they did. The doctor took your blood pressure. Then your doctor told you the pressure in Pascal. Huh? No. What did he tell you? I just give you a number. Alright? That number, okay, because the doctor uses a mercury manometer. Alright? Maybe these days the manometer disappeared, the mercury part disappeared. But traditionally, there was a tube, isn't it? Alright? When you got together the armband got the pipes and all that, the tubes connect to some glass tubing here, the glass tubing got some funny stuff inside here and all that. Okay? And then he pump, listen, and so on. Okay? I won't tell you what he does now because that's not fluid mechanics part anyway. So he tell you, let's say, your blood pressure, depends on, let's assume you're still quite healthy, maybe 120, I don't know, 70, 80, what else? 80, okay, 120, 80. Alright, what unit is it? In bar. mm. Okay, the unit is actually mmHg. What is that, Okay, so that's this obviously assumes, alright, this obviously assumes that your blood pressure is above atmospheric, correct or not? If your blood pressure below atmospheric, what happens? If you cut yourself, the air go inside. So unlikely that happen. So this is above atmospheric. Okay? Okay. Alright. Oh, I forgot to mention this one about air go inside. Absolute pressure. Before I continue, absolute pressure, this one must be always more than or equal to 0. Okay? kPa. Alright? So absolute pressure cannot go below 0 because 0 is vacuum, nothing there. Alright? Whereas your gauge pressure can go negative. Gauge like this one not meant to go negative, that's why there's a 0 here. If you suck here, it might damage the gauge. The needle might break because there's a pin there and it goes 0. Okay? But some gauges do allow you to go negative. Measure vacuum pressure. Alright? Vacuum pressure doesn't mean that it's 0, but pressure below atmospheric. So some gauges, alright, especially those used in refrigeration systems and all that, actually the gauge actually goes down to -1 bar. Alright? You cannot go to -2 bar because that violates this rule here. Alright? So you see some gauges actually goes to -1 atmosphere. Okay, that enable you to measure negative. Okay, so we assume this one is positive, it's not nobody leaking air inside. Okay, all right. So what it means, Okay, so this is in terms of pressure head. Okay, so this one obviously is in mercury. So the pressure head, we must know what the liquid is. All right, the doctor won't bother telling every patient, this is your 120 millimeters mercury. They just tell you 120. How do you figure out what the rest? Okay, but it's actually millimeters mercury. So pressure head is equal to, all right, the pressure is equal to rho G that multiplied by your pressure head. Okay, basically your rho GH, like we did earlier. All right, here rho GH. Okay, so your pressure head is equal to your pressure divided by rho G. Rho, in this case mercury, rho of mercury, G, 9.81. Alright, or G lah, put G for now. Okay, so let's convert. So the pressure is equal to rho of mercury is 13,600 kilograms per meter cube. G is 9.81. In this case, is 0.12 meters. Okay, 120 mm. Someone punch that into calculator. And 80 mm is the same. P is equal to same 0.08. How many Pascal? Normally not very high. What's the answer? 16.24. Okay, 16. This one? Huh? The 80 mm? 16245. It's very small. Alright? I think 600, isn't it? I think it's 600. Then wrong. What's the answer? Huh? 16009. This one? 10673. Okay? So between 10 to 16 kPa only, very small. Alright? Yeah. Alright? So when you cut yourself, you don't bleed out too badly. Huh? Quite slow process. Alright? Normally, depends where you stay. Just give you a feel of the pressure. Alright? Depends on neighborhood. I think if you stay in places like Cheras, where then you maybe got water problem there, isn't it? Because you have to ask Shabazz why lah. Okay? But if your area has no water problem, settle down. Alright, you get good water supply, good pressure at the mains pipe. This is the mains pipe that comes to your house. What you do in your house, your business. Alright? Normally you can get about 4 atmosphere, 4 bar like that, your pressure. Alright, between say 3, 4 up to 5. I don't find very high. Alright, between 3, 4, 5 bar. Okay, so mains pressure at your house. Alright, you stay in a good neighborhood, not in maybe what's the areas they were saying they got problem. Alright, so normally that one will be about 300 to 500 kPa. So this is your blood pressure about there. Okay, this is about water tap, and for the industrial processes, depending what you do, you can go a lot higher. Okay? Alright. Mains pressure, water pressure. Okay. So finally, any questions here before I move? Alright, so just to recap before we move on. So there's absolute pressure, there's gauge pressure, atmospheric pressure, and sometimes they also got pressure head. Okay? Another way of measuring pressure. Alright, in this case, we only did the example of mercury, but you could do it with other. They can say 10 meter pressure head of water, then you do the same, except here you use the density of water. Alright? Okay, final one. Alright, if you cannot cover it today, we'll continue. But okay, where? Alright, settle down please. Alright, assuming, let's start with easy one. Later on, the gate be on the side, the gate incline and all that. But let's say we have a gate at the bottom. Alright. Okay. Alright. Let's say this is water. Rho is 998. G is 9.81. Okay. Alright. What is the pressure on the bottom here? Okay. So first, alright. Well, we'll come to balance here. But first, we calculate pressure times force is equal to pressure times area, isn't it? Alright. What's the pressure? Depends on height, isn't it? Let's say what? 1 meter. Okay. So I'll say pressure is rho GH. Alright. Times area, let's say area here, A is 1 meter square. Alright. Times 1 meter square. Correct or not? Then some smart fella say, hey, hang on. I got per atmosphere. What? So, it should be P atmosphere plus rho GH times 1. Correct or not? So far okay or not? Yes or no? But then some next guy will come along and say, how about the pressure on this side? Alright, here we got water. What's the pressure on this side? Atmosphere, isn't it? Alright, assume it's all atmosphere back down to the bottom. So, and then going up. So depending on a sign convention, if let's say this direction is positive, okay, just right, minus times 1. Okay? So, this one bracket. Alright? So, you will end up with rho GH times 1. Alright? So, actually, that's the reason why, for this unit, most of the time when you need to calculate forces and so on, we use gauge pressure. Alright? In other words, we don't care about atmosphere. Alright? P atmosphere is 0. Because we're using gauge pressure. Because it makes no difference. It makes your life more complicated, but it comes to the same answer. Is that right? So if you use atmosphere, if you want to use atmosphere, I tell you not to, but if you really want, I won't stop you. But if you really want to use absolute pressure, make sure you have to consider the other side, what's happening also. Okay or not? Alright? But if you don't want to, then you can straight away go to this one, set P atmosphere as 0. This doesn't cancel out. Okay? So final example. H1. Okay, the top area A. Okay, this is water again. You okay about this one? All right. So now let's all just let's say that now I'll just do P atmosphere as 0. We do all our characterization in terms of gauge pressure. Okay. Let's calculate. Now these are all level surfaces. Next lecture we'll talk about when the surfaces are not level. Okay. So the force on top is pressure times area. Correct or not? The force below is also pressure times area. Correct or not? All right. So the force on top, I call this F1, F2. F1 is equal to, sign convention, again this way positive. Alright, F1 equals to minus rho G H1 times A. Is that alright? Force on 2 is equal to rho G H2. H plus H1 times A. Alright? Okay now. So the net force F1 plus F2 is equal to this one plus this one, rho G H A. Correct or not? Alright? Okay? Alright? What does this mean? What is the volume of this thing? H times A, isn't it? Rho GH times A is actually equal to the weight of water displaced. Okay? So you can calculate it from a few different ways, but what I've just demonstrated here is the buoyancy force is equal to the weight of the water displaced. Okay? Yes or no? Okay? So although I did it flat, but what happens if I turn this thing so that it's shaped like this? Any difference or not? No, right? Okay? So whichever, the buoyancy force is equal to okay. I think I'll stop here for now. Next class will come in. Those who want to sign or ask me questions, wait outside. Alright.